Hi again, everyone. Teacher Martin here, and today we are dealing with the force. Well, actually, force and motion, which is actually a very important part of science and physics. We are going to learn about the basics of force, its types, and how motion is affected by force. We're going to show how force works, and then after this lesson, you're going to learn the three laws of force and motion, okay, by a very famous scientist that you probably know of called Isaac Newton. All right, so let's get started with force. Three key questions for this lesson. What is force? What types of forces are there? And how does force affect motion? So these are the three areas we're going to touch today. All right. So what is force? So in physics, force is an interaction that has the ability to create or change motion in an object that has mass. Okay, so all objects have some form of mass, or basically that they exist. You can hold them in your hand, basically. That's what mass means. All right, so force is the ability to move something. All right, so we can explain forces as basic push or pull. So all forces, apart from one, which we'll talk about later, either push an object or pull an object. Okay, that's very important as we go through this lesson. Okay, and I want you to imagine a door. I think that's the best way I can explain it to begin with. Okay, so imagine a door. Now, to open a door, you either need to push the door or you need to pull the door. Okay, and then the same when we're closing a door, we need to push it closed or pull it closed. Okay, so a door requires force. Okay, and if the door is just a normal door, like in this image here, okay, you are the force creating that motion in the door. So you, your human body, can be a force. All right, that's very interesting. I hope you feel powerful about knowing that. Okay, so let's move on. Okay, now I want you to focus on this word here. Okay, in physics, I'll say this again. In physics, force is an interaction that has the ability to create or change motion in an object that has mass. So let's bring the doors back. Okay, now I want you to imagine the door is closing by itself. Okay, so imagine like there's a gust of wind and the door is slowly closing. If you go and grab that door and open it, okay, because you don't want it to close, you are changing the motion of the door. So the force can't just or doesn't just create motion, it can change the direction of that motion. So the door was closing and then you quickly grab the door and you pull it open. You've changed the direction of the motion. Okay, another way to describe it is imagine when you're playing pool. Okay, now your force is in the pool cue and you hit the white ball. Okay, so hit the white ball. Now you've created that force and the white ball is moving, it's in motion. Okay, but when it hits another ball, okay, that ball is also acting as a force. Okay, the ball will ping away from the other ball and change direction. Okay, so that's force changing direction. Okay, all right, let's move on. Contact and distant forces. I wonder what this means. So we have some forces that are called contact forces and some that are called distant forces. Okay, so let's have a look what these mean. Okay, contact forces are forces that we've already been talking about so far, and they act on contact, so they have to actually touch the object to make it move. Okay, so the best way to describe this is to imagine a ball being kicked. Okay, so imagine you go up and you kick a football or a soccer ball. Yeah, what is the force moving that ball when you kick it? So what is causing the force, or what is the force? That's right, it's your foot. Okay, so your foot is acting as the force, and that's going to move the ball. All right, and that is contact. All right, so that's a contact force. Now, a non contact force or non contact forces are special forces that actually work from a distance. So they can move objects without actually touching it, okay? And so one of those, one of the most common is a magnetic force. Okay, so magnetic force, okay, magnetism is a force, and it can pull iron from a distance. Yeah, so if you get a magnet, okay, and you go near some iron or a certain type of metal, okay, it will attract the iron towards the magnet. Okay, and that's the force, a magnetic force, and it's from a distance. Okay, it doesn't have to actually touch the iron or anything or the metal to move it. All right. And actually, the most powerful force in the universe, okay, don't get all Star Warsy on me, guys, is actually a non contact force. What do you think that force might be? Okay, we will talk about it a bit later. All right. I want to talk to you about the strength of forces. Okay, so the strength of a force depends on something called work. Now, I know we use the word work when we're talking about, oh, I have some work to do, or I need to answer some questions for Teacher Martin. We're not talking about that kind of work. Work is the amount of energy, okay, that is used in a force, okay, and the amount of that energy, the strength of that energy in a force, can actually change the motion of something. All right, we'll talk about it a bit more. So the amount of motion depends on how much work the force has. Does that make sense? I hope so. So the amount of motion a force creates depends on how much work the force has. All right. So let's have a little look at an example. We're going to use the football again. Okay, so if you kick the ball softly, what happens to the ball? Well, it travels in a very small distance, doesn't it? Yeah. So if we just tap the ball with our foot, it's not going to go very far and not very fast either, is it? Okay. However, if we give it a good hard kick, like a penalty kick, okay, the ball is going to travel faster and a lot further. Okay. And that is exactly what we're talking about. So when you kick the ball very softly, you're not putting much work, okay, into kicking the ball. So your foot as a force is not really giving much of a force, is it? Yeah, it's just going to travel a small distance. But the harder you kick it, the further it's going to travel, okay? And even with a magnet, okay, if we have a large, strong magnet, okay, it's going to pull objects from further away, isn't it? Yeah. And if we have a small magnet and it's weak, okay, we have to get closer to the metal, to the iron, for it to actually start to move, don't we? Okay, so that's exactly what we're talking about. The strength of forces. They are different, okay, and varied all over the world, all over the universe. Okay, so every force is different at different times, and it depends on how much work goes into the force. Okay, right, let's move on. Types of force now. Now, I told you before that all forces, apart from one, are push or pull. But it's very important to know that there are a few different types that we should know about. So even though forces are push or pull, there are a few different types. And I think it's good that we know about those types. So the first one we call just a normal force. All right. So a normal force can be you pushing against a door or pulling. So anything that's sort of physical, yeah, it's like a physical force. An engine driving a car would be a physical force, a normal force. Yeah, you kicking a ball or anything like that. Okay, pulling on a rope. They are normal forces because they're being created sort of naturally, if you know what I mean. What could we say? By material. Okay. The second one we've already discussed as well is magnetic. Okay, so magnetic force, okay, is caused by magnets. Okay, and there's lots of different types of magnetic forces. Okay, electromagnetism, okay, actually uses electricity to form magnetic fields and stuff like that. So there's lots of different magnetic forces. Okay, now the next one, believe it or not, is electrical. So electricity, okay, and I think this ties into the topic that we've been talking about, okay, is a force, all right? Think about it. All of the things that require electricity in your house, okay, they're being powered by something, all right? And that is electrical force, All right, electricity is a force. Okay, now the last one on this page I want to talk about is called air resistance. Now this comes under different names. Okay, it could be called drag or lift. Okay, depending. And we're going to have a look at it later on. Okay, air resistance is basically what's causing this helicopter to fly. The propellers on the helicopter, okay, are going around in a rotary motion, okay, and they are uh, basically creating air resistance. And air resistance is a force that's very important for flight. Okay, so aeroplanes, helicopters, and even birds, okay, they use air resistance to fly. All right. Okay, there are two types of force I want to talk to you about, and they're very important forces. Okay, this is why I've put them on this separate page. The first one is a force called friction. Friction, believe it or not, even if you've heard it before, is a force. Okay. Um, Now, a good example of friction. Okay, we have a look at this ball here. Now the ball is moving along, but eventually it's going to stop. Okay, especially on a flat plane. Okay, so if there's no downwards plane, if it's not rolling down a hill, okay, if it's going along a straight line, then eventually it's going to come to a stop, and that is because of friction. Okay, so the force is caused by two objects rubbing together, basically. So even though this ball is rolling, okay, it's actually still causing a rubbing motion on the grass, for example. And friction is actually what we call a stopping force. Friction is what stops movement or stops motion, all right? Now, depending on the object, okay, the surface of the object depends on how much friction there is, okay? For example, um, if we push this ball along, okay, and we cover the ball in grease, okay, or something slippery, it's going to have less friction, yeah. Um, Whereas if we cover it in something that's very coarse, like sand or sandpaper, yeah, it's going to have more friction, so it's going to stop much quicker. Okay, friction we're going to talk about in another lesson because it's a huge, huge area. All right, and the final one, you might have guessed it, is gravity. Gravity is what's keeping us on planet Earth right now. If it wasn't for gravity, we would be floating around in space. Okay, and it's neither a push or pull. Okay, so this is the only force that scientists say it's not a push nor a pull. Okay, however, it's the largest force in the universe. It's what keeps the whole universe together. So it keeps us on planet Earth and stops us floating away. It also keeps the Earth near the sun. Yeah, and it keeps the moon near the Earth. It's all gravity. Okay, now gravity is created from a central point. Okay, so the gravity of the Earth, okay, it comes from the center of the Earth. All right, and basically it's sort of like a spiraling motion. That's the only way scientists can really explain gravity. It's like a spiral. So we are being pulled, well, yes, kind of pulled to the center or spiral to the center of the Earth, and that's keeping us from floating off into space. All right, so that is gravity. And it's a very, very important force because it's everywhere. Okay? All right. I want to talk quickly about combining forces now. Okay, so there are many objects in motion, not just because of one force, but because of multiple forces working together. All right. So, what forces do you think are working together to move an aeroplane? So, what forces do you think are in play to keep that aeroplane in the air and also for it to fly along? Okay, if you guessed it was a pushing force and air resistance, you are correct. So, the pushing here we actually call thrust. So, an engine when it blows out the air, okay, like a jet engine, okay, we call it thrust, and that moves the plane along, okay. Now the air resistance in this case we call lift, okay. So the wings are what are causing the air resistance and lifting the plane in the air. So these are two forces, okay, working together to keep that plane moving, okay. What about if you kick the ball downhill? Okay, what forces are working together with that ball rolling down a hill? Think about it. Okay, so yeah, so obviously there's a pushing force that created the motion. Okay, because I imagine maybe there was someone stood at the top of the hill and they kicked the ball down the hill. Okay, and then gravity is going to do the rest. So gravity is going to keep that ball rolling down and down and down until maybe it hits that rock. Okay, if that rock wasn't there and it was a straight line, it would continue rolling until friction took over and the ball eventually stopped. Okay, so that's how we combine forces and they work together. However, some forces work against each other. Okay, if the forces are equal and working opposite to each other, or what we call opposing forces, they actually can cancel each other out and even stop motion. Okay, so let's have a look at this game of tug of war between two men. Okay, the two pulling forces, okay, are cancelling each other out. So both men are pulling at the same with the same force, okay, and they're not going anywhere. So there's no movement, there's no motion, okay, because the forces are working against each other. Two pulling forces are working against each other, okay. Now there will only be motion when one side creates more or less force than the other. So let's imagine this guy in the green top, okay, he gets tired, all right. Now he gets tired and now he has not, he doesn't have energy to put more force in. But this guy still has enough energy and his force overpowers this, and then they will all move this way, okay, and there will be motion then, all right. And another way, okay, to look at forces working against each other, okay, let's see what makes this helicopter hover. So we know that helicopters can hover in the air, so they don't go up or don't go down. Okay, so that is two great forces cancelling each other out. Okay, what forces do you think they might be? Yeah, you guessed it. It's gravity, which would push the helicopter down, but we've got air resistance or lift from the helicopter's propellers holding it up in the air. So we've got what we call opposing forces. So the helicopter can just sort of float in midair. All right? And that is opposing forces. And that is it. So thank you very much for listening. If you have any questions, leave me a message. And of course, may the force be with you.